What specific problem does the proposed method of adversarial post-training, APT, aim to solve in the context of one-step image and video generation using diffusion models?
The proposed method of adversarial post-training, APT, aims to solve the problem of generating high-quality images and videos in a single step, addressing the limitations of existing diffusion step distillation methods that require multiple inference steps. APT utilizes a pre-trained diffusion model, specifically the diffusion transformer, DIT, for initialization and then performs direct adversarial training on real data, which allows it to surpass the quality constraints imposed by the diffusion teacher. This approach eliminates the substantial computational cost associated with pre-computing video samples from the diffusion teacher and enhances the realism, fine details, and structural integrity of the generated outputs. APT is particularly significant as it achieves high-resolution video generation, 1280 x 720 at 24 fps, in a single step, a feat not accomplished by previous methods that typically generate lower-resolution videos in multiple steps. Overall, APT represents a novel advancement in the efficiency and quality of one-step generation in the context of diffusion models.
How does the proposed APT method work? Illustrate step by step, including the role of the pre-trained diffusion model and how adversarial training is integrated into the process.
The proposed adversarial post-training APT method begins by utilizing a pre-trained diffusion model, specifically the diffusion transformer, DIT, as an initialization point. This model is first distilled using deterministic methods to create a generator, denoted as HAT-G, which provides a rough initialization for the subsequent adversarial training. In the next step, the generator, G, is fine-tuned through adversarial training against real data, where it aims to produce samples that can fool a discriminator, D. The discriminator is also initialized from the pre-trained diffusion model and is designed to distinguish between real and generated samples, enhancing its learning capacity through modifications like cross-attention layers and an ensemble approach across time steps. This adversarial training process allows the APT method to surpass the quality of the original diffusion model, improving realism and fine details while generating high-resolution images and videos in a single step.
Can you provide a simple yet illustrative example that demonstrates the inner workings of the APT algorithm, detailing how it generates a video in one step?
The adversarial post-training APT algorithm generates a video in one step by leveraging a pre-trained diffusion model, specifically the diffusion transformer, DIT, as its initialization. Initially, the generator is initialized with weights from a distilled model, which provides a rough starting point for generating video samples. During the training process, the generator aims to produce video samples that can fool the discriminator, which is trained to distinguish between real and generated samples. The discriminator is enhanced with architectural modifications and operates directly on real, uncorrupted data, allowing it to effectively guide the generator towards producing high-quality outputs. By employing adversarial training against real data, APT enables the model to generate high-resolution videos, 1280 by 720, at 24 fps, in a single forward pass, significantly improving realism and detail compared to previous methods that required multiple diffusion steps.
What are the theoretical or practical advantages of using the APT method compared to traditional diffusion distillation methods, particularly in terms of computational efficiency and output quality?
The adversarial post-training APT method offers significant theoretical and practical advantages over traditional diffusion distillation methods. Firstly, APT eliminates the substantial computational cost associated with pre-computing video samples from the diffusion teacher, which is a common requirement in distillation methods. Secondly, APT allows for direct adversarial training on real data, enabling the model to surpass the quality constraints imposed by the diffusion teacher, leading to improved realism, better exposure handling, and enhanced fine details in the generated outputs. Empirically, APT achieves high-resolution video generation in a single step, 1280 x 720 at 24 fps, which is a notable advancement compared to previous methods that required multiple steps and produced lower resolutions. Additionally, APT demonstrates comparable performance to state-of-the-art one-step image generation methods, particularly in visual fidelity and structural integrity, showcasing its effectiveness in generating high-quality outputs efficiently.
How was the APT method validated or tested within the paper? Discuss the experimental setup, the datasets used, and any specific metrics for evaluating performance.
The APT method is validated through a series of experiments that compare its performance against existing one-step image and video generation methods. The experimental setup involves training the model first on images at a resolution of 1024px and then on videos at 1280 by 720 resolution, using a large batch size of 9062 for images and 2048 for videos, with a learning rate of 5e6 for images and 3e6 for videos. The datasets used are the same as those employed by the original diffusion model, ensuring consistency in evaluation. Performance is evaluated using several metrics, including visual fidelity, structural integrity, and text alignment, with user studies conducted to quantitatively assess the quality of the generated outputs. The results indicate that while the APT method shows improvements in visual fidelity and realism, it experiences some degradation in structural integrity and text alignment compared to the original diffusion model.
What are the significant results achieved with the APT method in terms of image and video generation quality, and how do these results compare with state-of-the-art methods?
The adversarial post-training APT method demonstrates significant advancements in both image and video generation quality. Specifically, it achieves high-resolution video generation at 1280 x 720 24 fps in a single step, surpassing previous state-of-the-art methods that required multiple steps and produced lower resolutions, 512 x 512 or 640 x 352. In terms of image generation, APT's performance is comparable to leading one-step image generation models, ranking second in absolute preference and first in relative preference based on visual fidelity and structural integrity, although it shows some limitations in text alignment. The APT method enhances realism and fine details while resolving exposure issues, outperforming traditional diffusion distillation methods that are constrained by the quality of the diffusion teacher. Overall, APT not only reduces computational costs, but also improves the quality of generated outputs, marking a significant step forward in the field.